So looking at worksheet 2, what questions do you have? Yes, ma'am, Kate. 15. And actually, before we even get there, I'm just going to write our lesson summary here at the top. Like, not even lesson summary, like entire unit summary is y equals a sine b x minus c plus d. Yesterday we focused on, we could back up all the way. Monday we talked about sine, cosine, and tangent without any transformations, without any changes. Yesterday we did changes to A, C, and D because you're familiar with those changes. C is a left-right move or translation. D is an up-down translation. And A, you're used to a multiplier out front, stretching it or compressing it. Today, later, we'll see what B does. And then after that, we'll just keep looking at this in different ways. Like today, we give you the equation and you give me the graph. Tomorrow and Monday, I'll give you the graph and you give me the equation. So it's the same concept. So if you get this, so the question of is this easy or hard, I don't know, but after we go over what B does, you'll be able to answer that question. Number 15. If y equals a sine x minus h plus k is the equation for the graph on the right, what could be the values for a, h, and k? Well, let's look at the graph on the right. And it's been moved down. Yeah, but where's the midline? So I don't want to say it's been moved down 5. Where's the midline of the graph? -2. So I would say it's been moved down 2. So that means k is -2. That didn't rule anybody out. I guess it ruled them in. It could be we're good on all of those. I want it to be a sine wave. Let's just handle them one at a time now. A is -3, so a flip and a height of 3. All their amplitudes are 3, so the 3 might be right. It's the negative that I need to be a little bit worried about. H is -2, so that means it's x plus, pi over 2. So careful with the negatives. X plus pi over 2. What does that do to the graph? Left, right, up, down?
Why does pi over 2 work?
Left pi over 2. Well, let's see. If we go left pi over 2, that would put us right here on the graph. Does that look like a sine wave?
Yeah.
Sort of. Why sort of?
It's upside down.
It's flipped, but they took care of the flip. So Roman numeral 1 would work because it would start here, it's flipped, but they accounted for the flip. Number 2, well, let's see. So x minus pi over 2, that means we would go right pi over 2 and start right here. So here's Roman numeral 2's sort of starting point. Does that look like a sine wave?
Yeah.
Yeah, without a flip. Oh, so that works too. So 1 and 2 are both good. Number 3. If h is 3 pi over 2, then that's x minus 3 pi over 2.
So you flip the sign.
Whoops, no, that's right. So that's right. Well, I'm just looking at what it gave me. So if I plug in 3 pi over 2,
That makes sense.
x minus, which means right 3 pi over 2, which would put me right here. So that works as a sine wave if it's been flipped. And it has, so all 3 of those are good. So that's a good question. That's a good review of what a sine wave looks like, shifting it left and right, also flipping it over. What else? Kate?
Can you also do 14?
Which 14 would you like me to do? The first 14 or the second 14? Second 14. Math teachers can't count. We do pre-cal and calculus, but counting past 15. This is incidentally about how my 4-year-old counts right now. Once we hit 13 or 14, it all turns into 14, 15, 13, 14, 15, 18. Working on it. Number 14, part 2. Graph y equals 2 sine x and negative 2 cosine x. Okay, so y equals 2 sine x. Even though there's not a lot going on with ABCD, I'm going to keep graphing them all that way. That way, I'm always just going to graph them with ABCD and then use DCBA. So A is the number in front. So amplitude is 2. B affects the period. There's not a change in period, so period's 2 pi. There's no C and no D. So all we're going to do is take our normal sine wave and stretch it by 2. So we'll start at 0, 0. We'll start over at 2 pi. And so I need to fit this picture onto 0 to 2 pi. So halfway in between, I'm at 0 again. Half of that, I'm at a maximum, but the maximum's up at 2. Minimum's down at negative 2. So there's y equals sine of x, but stretched. And let's copy it over into the negatives. Yeah, my sine graphs are looking good. All right, negative 2 cosine of x. So a lot of times I'll do a quick sketch of the parent function to remind myself what the original looks like. A is negative 2. Okay, what's the negative part of negative 2 mean? Flip. B is 1, so we have our normal period of 2 pi. There is no C and no D. So no D and no C, so I'm still starting at 0. I'm going to 2 pi. Cosine normally starts at a max, but this one's going to start at a min because it's been flipped. So I need to start at negative 2. And whatever y value it starts at is the same y value it ends at because it's going to start over there. So like sometimes if it gets complicated, people start labeling their points. Like that point A got flipped to this point. That point B got flipped to this point. Halfway in the middle, we're normally at a min, but we've been flipped, so we're at a max. And then halfway in between there, we're at 0, and we could flip 0 and still get 0. And then we'll copy that over into the negatives. So 2 pi away, minimum again, halfway we're at a maximum, half of those were at 0. So there's my 2 pictures. I think so too. I mean, I know I'm a math teacher, so that makes me nerdy and weird. I get that. But I like this section because if you can do it and do it neatly, I think you end up with cool looking graphs. But that's just me. Describe all the values of x at which the 2 graphs intersect. Well, they intersect there, and there, and there, and there. Now that's not much of a description to just say there. So they intersect at x equals. Let's pick the easiest one first, I think. So this one that's closest to x equals 0, what x value is that? Negative pi over 4. Because it's in between 0 and pi over 2. Another intersection is right there. What's in between pi over 2 and pi? 3 pi over 4. Then way over here, in between 3 pi over 2 and 2 pi, I don't know, I'm at least thinking in my head, and maybe it helps to even draw it out. 3 pi over 2, 2 pi. So yeah, that's 7 pi over 4. If the picture helps. And that other one was over here at negative something. In between pi and 3 pi over 2 would be 5 pi over 4. So negative 5 pi over 4. I don't know what it means by describe, but I think listing them is what we're talking about there. The places they intersect. Do we need to do something from 7 through 10? Those are the graphing ones. A tangent one? Let's do number 7. We can hit it. I want to do 7 because it's harder with the fraction and we hadn't done a cosine. Well, I guess we did do a cosine. We've done more sines than cosines. So let's do number 7. All right, cosine. Again, probably the first thing I should do is do a quick sketch of the parent function. I know what cosine looks like. Now I've got to make all these changes to it. Again, all the rest of this unit, I'm going to be saying A, B, C, D, D, C, B, A, again and again and again. So A is negative 3/2. That tells me it's amplitude, but it also tells me it's been flipped, so I better be careful about that. B is 1, which means my period is 2 pi, because it hasn't changed. Because we're not messing with period yet. We'll do that today. C, what are we doing with that minus pi? Good. And good. Don't worry about telling me if it's minus or plus. Tell me what it does. Write pi. That's the easiest way to say it. And then D, what does that minus 1/2 do? Down 1/2. All right, so I found A, B, C, D. Now I use them in reverse order, D, C, B, A. So down 1/2. That's kind of annoying that it's a fraction, but I can do down 1/2. Right pi will be the location of my new origin. So if I go right pi and down 1/2, that's kind of my new starting point. That's where my parent function is going to start now. DCBA. So going backwards, 2 pi. So I need to go 2 pi away from pi. So where will that land me if I go 2 pi away from pi? 3 pi. Why is that a problem? It's well off the graph. It's not just like 1 hash mark off the graph. It's like 2 hash marks off the graph. So rather than going forward 2 pi, how about I go backwards 2 pi? And if I back up 2 pi, that would land me at negative pi. And I'm going to go ahead and put a new origin marker on that as well, because it doesn't really matter which one you start at, because it starts over. It's cyclical. So in between negative pi and positive pi, that width is 2 pi. I need to fit my cosine graph, except that it's been flipped and its amplitude is 3/2. Okay, so normally we start at a maximum, but we've been flipped, so I need to start at a minimum. So how far away from the midline do I go? Like, how far down do I go? I go 1.5 down, because maybe I should have written it as 1.5. Maybe a little easier. So if I go down 1.5, I land at -2. There's my new point A. It's been flipped over. Which means my ending point should be the same type thing. Sounds like a Hallmark card or something. Every ending is a new beginning. And maybe not in life, but on sine and cosine graphs, it's absolutely true. Every ending is a new beginning. And so if it starts at -2, it ends at -2. Halfway in between the two maxes is a min, at least normally a min, but we're flipping, so we need to be at a max. So halfway in between, and then I need to go up 1.5. So that would put me at 1. And then halfway in between a min and the max is 0. Although zeros now are kind of a different 0. They're a midline 0. And it does say graph it between -2 pi and 2 pi. So that's sort of my parent function first cycle. But I can just follow the pattern and extend that. The next point would be on the midline, and then the next point would be a maximum. Same thing going backwards. Midline, maximum. There's my nice little cosine wave. Suggestion that you don't have to follow, but I think would help, maybe help you catch a mistake. Most students get the ABCD right, like they can get that right. That's not hard. The error comes when they try to translate or try to go from the values to the graph. So when you're done, you should look at your graph and see if it matches what you said would happen, because almost always you get what said should happen right. It's just doesn't make it over. So we have an amplitude of 1.5. Yep, that's what's going on in my picture. Period is 2 pi. Yeah, from 0 to 2 pi, we see the whole thing. That's one cycle. We started by going right pi, and our vertical shift was down 1/2. So kind of a quick check. All right, let's move to